I'm going to demonstrate how to use an interactive simulation for compressibility factor charts. And this simulation is located at the link shown here on the LearnChemE site. And what the compressibility factor chart plots is the compressibility factor, Z. So notice this is pressure times molar volume divided by ideal gas constant and temperature. And so Z should be 1 if we have an ideal gas. And we're plotting this versus reduced pressure. So that's the pressure divided by the critical pressure. And then as a parameter on the plot, we use reduced temperature, which is temperature divided by the critical temperature. Of course, these are all in absolute units of temperature. And what we are using in this simulation are 5 molecules because the compressibility value for the equation state we're using depends on 3 parameters: the critical pressure, the critical temperature, and the eccentric factor. And the eccentric factor is different for these 5 molecules, so the plots are different. So what we're looking at here is carbon dioxide, and you notice at the higher temperatures that the compressibility factor approaches 1, approaches ideal gas. But at the lower temperatures, it can deviate significantly. And then likewise, at the lower pressures, we see some significant deviations. And of course, this is around the critical pressure. But at very low pressures, of course, we have an ideal gas. They all go to 1 as the pressure goes towards 0. So let's look at this simulation. So the simulation has the details that shows the equation of state used, the Redlich-Kwong equation with the Solvay modification, and shows the parameters that are dependent on critical temperature, critical pressure, and then further down here, the eccentric factor, omega. So what we can do with the simulation, we can move this black dot, which shows any value of reduced temperature, and then, of course, reduced pressure, and then we can read off the compressibility factor. If we switch to a different molecule, you notice these plots change some. They change perhaps more for hydrogen, but the idea is that we can model the behavior of a non-ideal gas, and the plots of compressibility factor versus reduced pressure allow us then to, for example, if we know pressure and temperature, we can determine then the specific volume for the gas.